Let us start with convolutional codes. Convolutional codes. Now what is convolutional codes? Convolutional codes provide better error correction performance. It provides better error correction performance. Second point is it has low C by N ratio, carrier to noise ratio in the receiver. Carrier to noise ratio plays a very important role in satellite communication. So it provides low C by N ratio in the receiver and have simpler decoding structure. The decoding structure of convolutional encoder is very simple, simpler decoding structure. Third point is convolutional codes are generated by a tap shift register. For the generation of convolutional codes, we need tap shift register along with two or more modulo 2 adder. Two or more than two modulo 2 adder. Now what is modulo 2 adder? Modulo 2 adder is a simple XORing of bits. Okay. Now here we will see the XOR table. A and B are the inputs, Y is the output. The combination is 0 0 0 1 1 0 and 1 1. Now if both the bits are 0, then output is 0. Mean both the bits are same, then output is 0. Here both the bits are 1, output is 0. If one of the bit is 1, then output is 1. 0 XOR 1 is 1 and 1 XOR 0 is 1. Okay, so modulo 2 addition perform using this XORing. Okay, now we will see the figure or diagram of convolutional encoder using 3-stage shift register. Now the diagram of convolutional encoder is, this is a 3-stage shift register. Now as the stages are 3, therefore there are 3 shift registers. This is D0, D1 and D2. Now the shift register means the bits will get shifted to right position. Now here we are giving input to the shift register from left side. Okay, and here is the modulo 2 adder. As I told you, modulo 2 adder is, or addition is, nothing but the XORing. See this first modulo 2 addition, here we are giving D0, D1 and D2. These 3 bits we are giving at the input of this modulo 2 adder, okay, and here we are giving 2 bits to the modulo 2 adder, that is D0 and D1. Here a switch is connected and here we will get the output. Now the bit sequence is 0, 1, 0, 1, 0, 1, 0 and 1. The output of this modulo 2 adder, first modulo 2 adder is x1 and here it is x2. Now x1 is the XORing of D0, D1 and D2. So here I can write D0 XOR with D1 XOR with D2. Here I can write x2 is equals to D0 XOR with D2, and here there is a switch. Now as we know that the function of switch is it will get switched from this position to this position, one position to other position it will get switched, okay. So right, so this is x1 and this is x2. Now what happened here, first bit will enter into D0, that is 0, and yes, initially all the bits are 0, this we have to remember that initially all the bits are 0, that is D0, D1 and D2 is 0, and then when 0 is entered into D0, then the bit which is stored in D0 will shifted to D1 and bit which is stored in D1 will shifted to D2, and then one by one x1 is nothing but the XORing of D0, D1, D2. So XORing of 0, 0, 0 is 0, okay, and here XORing of D0 and D1, it means 0 XOR with 0 is 0, okay. Next page, here I will explain how it happens. What is the bit sequence? 0, 1, 0, 1, 0, 1, 0, 1, okay, and here shift register D0, D1 and D2, D0, D1 and D2, okay. Initially all the bits are 0, right. Now when this first bit entered into D0 register, here I am writing x1 and x2. As we know that here I am writing x1. What is x1? x1 is the XORing of D0, D1 and D2, and x2 is XORing of D0 and D2, okay. Now when first bit is entered into first register, then the previous bit of D0 will shifted to D1 and D1 bit shifted to D2, means here 0, 0 will shifted here, okay, and here second bit will enter. Now what is here x1 and x2? The XORing of all the bits is 0 and x2 is D0 XOR with D2, therefore 0 XOR with 0 is 0. When this bit 1 is shifted here, bit 1 entered into D0 register, okay, in second clock cycle, then 1 XOR with 0 is 1 and again 1 XOR with 0 is 1 and 1 XOR with 0 is 1, okay. Now in next clock cycle, this third bit will enter into this D0 and the previous bit will get shifted. So 0 XOR with 1 is 1 and 1 XOR with 0 is 1. For x2, 0 XOR with 0 is 0. Coming to the next bit. In next clock cycle, what happened? This one bit will enter into this D0 and the previous bit will get shifted. This D0 bit shifted to D1 and this one shifted to D2, and here the bit is 1. Therefore, what is x1? x1 is modulo 2 addition of 1 0 1. So 1 mod with 1 is 0. Okay, and x2 is modulo 2 addition of 1 and 1. 1 1 is 1 XOR with 1 is 0. Therefore, it is 0. Okay, next clock cycle. In next clock cycle, this 0 bit will enter into this D0 and previous bit will get shifted 1 0 and here 0 will enter. So XORing of 0 1 0 is 1 and XORing of 0 0 is 0. Similarly, in next clock cycle, this 1 will enter, previous bit shifted here. Sorry, it is like this. So 1 XOR with 1 is 0, here 0 and here also 0. Then 0 bit will enter, 0 enter and these bits are shifted. So x1 is 1 and x2 is 0. And for next position, these bits are shifted 0 1 and the last bit is 1. Therefore 1 0 1 का XORing अगर करते हैं तो क्या आएगा 0 and 1 XOR with 1 is 0 again. Okay, now the sequence x1 x2 is like this. Now in previous we have seen that the output of convolutional encoder is taken from the switch, है ना. Here switch was there and the position of switch will get shifted from one to other. Here x1 and here it is x2. Okay, so initially x1, what is x1? x1 is 0. Then switch will come here, then the second bit will goes to output, that is 0. x1 x2, the combination is x1 x2 x1 x2. So 0 0, then 1 1 is 0 0, 1 1 1 0, then again 0 0 1 0, 0 0 1 0 and 0 0. So these are the output bits. This is the output of your convolutional encoder. Convolutional codes are also called as Viterbi codes. Convolutional codes are also called as Viterbi codes. The algorithm used for decoding is named as AJ Viterbi. For decoding, which algorithm is used? AJ Viterbi. For decoding of this convolutional codes, AJ Viterbi algorithm is used. Therefore, convolutional codes are also called as Viterbi codes. So this is all about the convolutional codes. Thank you.